Hello, welcome to my channel. I remember that the last time I did a live stream, I did the seventh problem named reverse integer. Reverse integer is an easy one, so it didn't take too long for me to finish it. And after that, I have some days working on my own on some problems from 8 to 15, and because of some technical problem I did not live stream all these problems, so I just want to give you a quick glance at all of these problems. Each problem named string2 integer. So in this problem, we have to convert a string to the integer, and there are many other characters may appear in these strings. For example, it can has many white space before the side um, character and the numeral character, and then there may be many other uh, alphabet character from A to Z, and so all these third example legal example means that we still can get the output. We still can retrieve the number from that string. However, if before the number are not a non-white space character, we have to return 0. So in this solution, I did a while loop to go from the first character in the string until the end of the string, and I check whether it is digit or not. If it is a digit, I have to calculate which one it is. And also because we have we also have some limitation here, like if it's smaller than uh, than the minimum value of integer, or bigger than the maximum value of the integer, we have to return that border value, like here is the minimum value of the integer. So we have to compare uh, the number before we do the calculation. Like if the current number we already have is bigger than the max value divide 10, we have to stop there and we have to return the max value. It's the same for the mean value. Just in my solution, I use sign to record whether it is an, a negative number or not. So before I solve the problem, I also list some test cases that I think maybe appear in the test use, like the normal case, or many white space before the number, many non-white space after the number, one or many non-white space before the number, or bigger than max in or smaller than min in. So That's a quick glance at the edge, the problem edge. Now I want to, let me show you how well I did. So the accepted, yeah, I already had many wrong answers before I go to the accepted one. So it is 2 millisecond, and it is better than about 80% of Java submission. It's not a very good result, but it is acceptable. So I move to the next one. The next one is palindrome number. It's an easy one. So we have to check whether a number is palindrome or not. Is a palindrome or not. So we have like 1 to 1, it is true. Minus 1 to 1 is false, because when go from left to right, it reads minus 1 to 1. So it is from right to left, it is 1 to 1 minus. So it is not palindrome. So obviously, all the negative number is not a palindrome. So here in the solution, I write that if it is smaller than 0, so we return false. We don't have to do any other steps, any step to check. And the final example is 10, so it's 0, 1 from right to left, so it's not a palindrome. So here I use a variable named reverse number, also an integer, and I have to store the value of x into another value, because I will change it while I calculate the reverse number. So while x is still bigger than 0, I did the reverse number by calculate from the digits, and then I change the x to make it smaller and to get each digit. And finally, if the reverse number is equal to the value, so we return true. If not, we return 4. And I try many times. The first time is wrong answer, and then many accepted one. I just try to find the quickest way to do that. So here the runtime is 6 milliseconds, and here beat 100% of Java submission. So I assume that is the best way to solve that problem. And now we will come back to the list of problem and move to the problem 10, regular expression matching. In fact, I already read the problem. I tried to solve it in I guess 1 hour, but I did not come up with any solution, so I just leave it here. And I think I can do it. I can live stream it after I finish all the summaries of all the problems I finished. So next we go to the problem 11, container with most water. It's also an a medium problem. So here we have many, we can say that it's line. So that line, the first line have the height is 1, the height is 1, and the second one is 8, the third one is 6, and then um, many other like here. So the question is, what two lines will make the biggest container. That means the area. So here we have the second one and the last one, and the highest, the longest height is 7. So we have this one is 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's also 6 here. 9 minus 2 is 6. Oh, sorry, is 7. So the area is 7 multiply 7 is 49. So here, the mass area of water, blue section, the container can contain is 49. So with the, we have only one example, and the output is 49. The first solution I have taught is was just compare every couple. So I do 2 loops. The first loop come from the first one until the last one, and the second loop come from the previous index plus 1 to the last one, and I calculate the area of these two, and I can show you that that is my first submission here. So I do two for loop, and I calculate the area, and it max is smaller than that, so I uh, give that value to max and return max. I think that is the um, most obvious way we can do, and the runtime is very long, and I don't know where I was, but it's very slow. And then I came up with another way. It's much faster here. So it's beat 96% of Java submission here, because we have to um, the maximum error when appears when we have the distance between the two lines is furthest, and the height of the shorter line is maximum. So we will go from, it means that if I am, for example, I choose a line um, at the beginning, so it's better to have another at the end of uh, the end of the list of all lines. So the distance is far, and I so that is the best result we can have. So I start one thing from the start and another from the end, and I go kind of if the end is better than the start, then we have um, we 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 choose we calculate the area based on the start one, and then we move to start. I mean, we increase the start. But if the light at the end point is shorter, so we calculate based on the end, and we move the end forward. So that's make it run very it run faster, because we only run through the half of the line. For example, we have n line, we only have to run the loop through n divide 2, a half of n, in compared to the complexity of n square is much faster. So that is the problem 11. Problem 12 is how to convert a number from the integer to Roman. We have the symbol. I guess you already know about that from 1 to 1000. And we also have some rules for 4 and 9, 40, 90, 400 and 900. So like here with 4 we have this one, not for I mean that it's not that way. So here it's quite obvious that we have uh, two arrays. The first array is the number in integer, and the second is the number in Roman. And I run from the first one to final one, that if the num is smaller than the value here, like for example the number is smaller than 900, so we move forward to 500. And if not, we will calculate like the count. We check how many character we will use. Like for example, if we have 3, so we have to put 3i next to each other. So here I see how much of the number, I mean of the character, Roman characters I have to use. And after that I subtract it from the number. So that one is an accepted one, but it's not fast enough. Here it's only 30% of Java submission. And it's quite interesting that even with the same one, but I set the value of each element in the array, I have quite faster way. Here I can show you with one run only 5 milliseconds. So it's the same code, that same code. However, different initialization here. It beats about 70% of Java submission. Here, the only difference is I make it manually. It looks crazy, but it runs faster. It's quite interesting. However, even 70% is not a very excellent result. So I'm curious how to make it run faster. So, but the solution is not open. It means that you have to buy the premium to read the solution. So it's still a secret to me. The next one, 13, is Roman to integer. Another is easy one. Yeah, it's easier than convert from integer to Romans. So I just read um, each character and convert, just to take a little bit import, important important things is if we, for example, with the m or anything that can go with something to minus it 1. So here with m, uh, if the previous of it is not c, so obviously I can make the result is result plus 1000. However, if it already has the c before that, it means that cm is only 900. And before that, when we receive, we already increase 100. So here we only increase 800. And because we use I use squeeze case, it's quite fast. and the submission only one time is quite fast. It beats 100% of Java submission, so I'm happy with that result. Another one is the longest common prefix. So it means that if they give the list of string, we have to return the longest prefix that appear in every element of the array. So here I set the prefix to the first element of the string, and then I go through all the string in the array from the next one, the second one until the end. And I will calculate if the length of the current string is shorter than the prefix. We only run until the end of the prefix, and we will cut out the prefix to get the shorter one. So it's quite obvious, but no, it's not the best solution. Let me see. So it's only beats 64% of Java submission. So here we have some other solution, and the time complexity is normally OS. So it's quite similar to what I did here. However, in some way, the best case will have much better one, and I think the best one is binary search, and the complexity is OS log m. And but I didn't read it carefully, uh, so I didn't quite I didn't try to implement it. And if you want to have a faster way, you may check it. It may be a good way to solve the problem. And then I go through the three sum, and I also have some achievement. I already have the solution using the hash map. I tried here, I have to come back to the problem first. So given an array nums of n integer, are there elements a, b, c in nums such as a plus b plus c equal to 0? And notice that the solution set must not contain duplicate triplets. So for example, here we have -1, 0, 1, 2, -1, -4, and the output we have two of that. So it means that even we have here -1, 0, 1, and 0, 1, and -1 here, it only appear once in the output. So we have to eliminate the duplicate triplets before we return the result. In my solution, I sort it first. Oh, sorry. This is another solution. Here in the solution, I have the hash map, and I run 2 for loop. And then I check whether the final element of the triplet is already in the nums array or not, using the set. So before that, I calculate the hash set. The hash map. The hash map is the key is the sum, and the value is a pair of 2 index. So for example, I have the sum 0, and the value will be -1. Will be 0, the index of the -1, and 2, the index of 1. And after that, I will iterate through the array nums to create the triples from couples, because we already have the couples before. So now we only have to find the final ones. And that way I did the same way with the 2 sum we already solved before. You can find it in the list of the problem. And finally I return the array. This one have the result only at 28% of JavaScript, and I guess before that I have some not another way that is quicker. So here 28% is the best. I guess I have to find another way to solve that. But the 21st, I mean the around 30% is another way. So in this way, I sort it using quicksort. Sort the value using quicksort. And then I find the index of first non-negative number. And I create a set of all the number. Then I iteration. The first round, the index will goes from the beginning to the first 0. So it means that only the negative number. And the second round go from index of first round -1 until the end of array. So it will be non-negative number. And then I use binary search to find the final element of the triplet. And if the new triplet isn't in result set, I will add it. So that solution run and faster than only 30% of Java submission. I think I have to find another way that is faster. And again, with this problem, the solution is still locked. It means that we have to buy the premium user to open it. So in conclusion, I see that I have to start again with I have to redo the 3 sum and find another way for regular expression matching, and I will do it next time. So thank you for going with me through the problem 8 to 15, and I will give the summary in the description of this video. Thank you for being with me, and see you again when I solve the problem 10, regular expression matching. Bye bye.